Lesson 4.4, Proving and Applying the ASA and AAS Congruence Criteria. This is very similar to the previous lesson. It starts out with trying to contradict or find a counterexample. So it says, make sense and preserve. Assume that the triangles are not congruent. So you're looking at these triangles, they have the exact same measurements here, the angles are the same, but you are going to try to think of an example, a counterexample, to prove that these are not the same. See if you can do that. And then is sufficient to say that the triangles are congruent because of what you might have found, or is it not enough? So this is kind of, I want to see what you know, your teacher probably wants to see what you know, and just can you think of a way to prove that these are not congruent through a counterexample? Example 1. So angle, side angle is a criteria to prove that triangles are congruent. So if you look at this angle, or these triangle, it gives you 25 degrees, 3 centimeters, but it says, can you determine when given two angles in the included side of a triangle if they would be congruent or unique? So let me show you, and I love this manipulative. If I move this, notice this 25 degree and this 3 is not changing, but this angle, the 106, that's changing. So if I made a huge angle, 129 degrees, is there a way that I can make a different triangle with 25 degrees, 3 centimeters, and 129 degrees? Like, is it even possible to create a different triangle that's not congruent to this? So this explains it, and it says it's not. These are each unique. So what this rule says up here is that if you have an angle, a side, and an angle, that order matters. So an angle over here, an angle over here, and the side in between them, where that side is in the middle, like that 3 is in the middle. If you have two triangles with angles, side, and angle that are congruent to two angles, side, and angle of another triangle, they will be congruent. They are not different. They're completely the same, congruent. So look at this relationship. Angle, side angle matches up with this angle, 25, side angle. It says, what is the relationship? Well, first of all, based on this rule, angle, side angle, that we're going to go over soon, that they will be congruent by the angle, side angle criteria. But looking at this relationship-wise, it's just a reflection. So if I put the line of reflection right here, vertical line, that would be a reflection of the other one. Here's the rule, angle, side angle. And it just explains if the angles, two angles of one triangle are congruent to two angles of the other triangle, and the side between them, they're the same, then the entire triangles are congruent. Both triangles are congruent by the ASA criteria. Now we're going to do like a little proof of this using rigid transformations. I'm going to push play, and I'm going to have us watch this, but I'm going to turn off the volume here, and I'm going to walk you through it. So it's similar to a previous lesson, and it's going to show us how these triangles, see those angles? There's another set of angles. These sides, oops, right there, those sides are congruent. And they're going to use a way to map one of the triangles onto. So first is a translation, then it's a rotation, and finally it's reflected across that line. And so by rigid transformations, you can tell that they map one triangle onto the other without seeing it, and they are definitely congruent triangles. Describe the series of transformations. Every single person could have a different variety of this. So you need to decide, how am I going to move this K onto point N? And the reason why I know K goes onto N is because, one, the markings, there's a single arc mark, but also see where K is in the middle? N is in the middle. That order matters. So point J would match up or correspond with point M. So point J should line up with point M. So make a list. How would you move it, rigid transformations, to get one of the triangles mapped onto the other? And now we're going to apply this rule. So here's an actual problem. A technician installs cables from a cell phone tower to the ground. So here's the tower, and here are some cables. To pass the inspection, both cables must be the same length. So each of these must be identical, which, see these triangles? There's one on the right, and here's one on the left. They have to be identical. So we're going to use the angle, side angle. It tells us that. So here's an angle. They share this same side. So definitely that side is congruent on both triangles by the reflexive property, because they're the same on both triangles. And then 90 degrees is an angle. So angle, side, angle. If it's 90 on one side and it makes a straight line, it has to be 90 on the other. So angle, side, angle. So you can prove it that these cables are the same because the triangles are congruent. The side lengths would be congruent. And there's that rule that comes up. Once you prove the triangles are congruent by angle, side, angle, then you could say CPCTC, corresponding parts, these cables, those parts, corresponding parts of congruent triangles would be congruent because the triangles are congruent. Okay, are these congruent? So again, watch that order. JK matches up with MN. So JK, see how there's a single tick mark? MN, single tick mark. Then match up the angles. Angle J, does that have the same markings as angle M? J, M, and go from there. And you determine if those are congruent by angle, side, angle. There's another one, I believe, down here. You need to check these triangles. Check these on your own. See if you can figure out if the markings from JKL and triangle PQR match up perfectly, that they would be or would not be congruent to each other. Here is another criteria. So we've already done side, angle, side in the previous lesson. We've done side, side, side in the previous lesson. And then this lesson uses angle, side, angle, 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 side. So here's a fourth one. So we need to determine if this is unique or if you can make another triangle with this angle, and that exact side. So looking at the solution, it's a little bit hard to determine, but I want to show you this math. If you had 3 triangles in a triangle, they will always equal 180. So if I know E and B, those angles are the same, A and D are the same, then these third angles would have to be the same. So C is congruent to F. Now, if C is congruent to F, that's angle, side, angle. Angle, side, angle. So then we're like, hey, we can use that rule that we just learned, but you can keep going. And it actually goes through every step that these triangles are congruent. And the new rule is angle, angle, side. Okay, using this, can you use rigid motions? Again, use that translation, rotation, and reflection to get one to map onto the other. And your order that you write it in could be different than mine, and it could be different than the answer key. So just be aware of that. So this is the rule, and I already told it to you, but here it is. Angle, angle, side. If you have a triangle that has 2 angles of one triangle congruent to 2 angles of another triangle, and then the side. Now, notice I said the side. I didn't say the side in between. It has to be afterwards or before. So here, see how the side is marked here, and then 2 angles? The side is marked here, and then 2 angles. Side, and then 2 angles. So some teachers, some textbook might call it SAA. That's fine, as long as there's 2 angles together, and then the side is after, or the side comes first, and then there's 2 angles together. So you can write this rule. It's written either way, AAS or SAA. But that proves that 2 triangles are indeed congruent to each other. All right, using triangle congruence criteria. This says, state whether each pair of triangles is congruent. You have to use one of these 4 rules. So those 4 rules, side, angle, side, 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 angle, side, angle, and AAS have to be used. So if you cannot find a rule that says these triangles are congruent, then you cannot say that they are congruent. You would just say not enough information. Some textbooks say not congruent. Now, technically, they could be. You just don't have enough information. So usually we just say not enough information. So I'll do this first one with you. Angle, side, angle. Notice the markings. Angle, side, angle. They definitely match up. Those would be congruent by angle, side, angle congruence. So go ahead, the solutions will show up if you do them, but go ahead and see if you can actually identify all of those sets. All right, proving this. This is an actual proof. I've been talking about getting better at proofs. So given, how do you start every single proof that we've done so far? You start with a given. So I'm going to look at this solution, and it's a slide down. So first it starts with the given. Now just look at the picture. I'm hoping you can figure out what rule, angle, side, 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 angle, or angle, angle, side, which one of those rules will show that these triangles are congruent? Angle, angle, side, angle, angle, side. Okay, once you see those, you can say, oh, these triangles are congruent by angle, angle, side. But that's not what it's asking us to prove. It's asking us to prove that FH is congruent to JL. Those are the two sides. If the triangles are congruent, the parts are congruent. And there's a name for that rule. We did it in our last lesson. It is CPCTC. Corresponding parts, in this case side lengths, are congruent. Corresponding parts in congruent triangles are congruent. So if the triangles are congruent, which we just proved, then the parts will be. You'll be given more proof examples and practice problems like this. Okay, I love these. This is what additional information do you need? So angle, side, angle. So I look at this. I have an angle and a side. I don't have the other angle. You have to identify exactly which angles would have to be congruent to meet this rule. This one, same picture, but you would have to say which angles needed to meet this rule, angle, angle, side. So where would they have to be positioned to make those triangles congruent? And then this one, this seems really complicated at first. It's congruent polygons, but as you get going, it should be a little bit better. Basically, you take any polygon you're given, no matter what the shape, it's a polygon, break it up into triangles. So notice it's broken up into two sets of triangles. Prove that each triangle set is congruent. Then you can prove the polygon's congruent. So if I take triangle ABC, ABC prime, those are congruent by side, angle, side. Then I take these other two triangles, ADC and ADC prime. They are also congruent because of side, angle, side congruence. If you have two triangles that are put together to make a polygon, then that entire polygon would be congruent to the other entire polygon. It goes through the solution step by step for you, but it's kind of nice to know the concept. Just break it up into congruent triangles. Okay, given ABCD is congruent to EFGH. Remember, order matters. So point A lines up with E. A lines up with E. Notice it's rotated. And D, I'll go to D. D lines up with H. D lines up with H. So this base up here, this flat and perfectly horizontal side, matches up or corresponds with this. It's saying these are congruent. So that means to solve for X, I would have to say 9 is congruent to 2x minus 3. Congruent to, that's like equals. So I'm going to see if I can shrink this for a second. I'm going to write this down. 9 equals 2x minus 3. 9 equals 2x minus 3. Well, you solve for x. I know the triangles are congruent, so these two side measurements are congruent, which we set equal. I'm going to add 3 to both sides. So I have 12 equals 2x. And keep going, divide by 2 on both sides. I have x equals 6. Now, just to make sure, I'm going to go back to my original screen. And just to make sure I'm on the right track, if I plug in x, which is 6, 2 times 6 is 12, minus 3, yep, it's 9. So you always want to double check if you plug them back in, if you would get the same answer, because they are equal, which means they're congruent, which means these numbers should be equal, and set them equal to each other. Okay, big picture. You have 2 new rules today. Angle, side, angle, and angle, angle, side. Those are 2 more rules that prove triangles are congruent. I hope that helps.